Hello everyone, welcome to the world of robots. Today we will be continuing with few more sensors. An accelerometer is a sensor used to measure the acceleration of a device and the acceleration due to gravity, that is the orientation of a device. It can determine if the device is parallel to Earth's surface or it is tilted at an angle. Let us see what is the principle of operation of an accelerometer. The essence of accelerometer functionality lies in the conversion of mechanical motion into an electrical signal, a process achieved through the piezoelectric effect. This effect is observed in certain materials that generate an electrical charge in response to applied mechanical stress. In the context of accelerometer, when acceleration forces act upon the device, they induce stress on the piezoelectric material within. This stress leads to the deformation of piezoelectric crystal, generating a charge that is intrinsically linked to the magnitude of applied force and thus to the acceleration. Applications. In case if the laptop were to suddenly drop while using it, the accelerometer would detect the sudden fall and immediately turn off the hard drive to avoid hitting the reading heads into the hard drive platter. Mobile phones keep changing the screen mode in landscape or portrait mode due to the accelerometer applications. Gyroscope. A gyroscope sensor is used for measuring or maintaining orientation and angular velocity. Gyroscopes are fundamental in many applications where precise orientation control is needed, such as aerospace, robotics, smartphones, and navigation systems. Now let's see the principle of operation of a gyroscope. The gyroscope relies on conservation of angular momentum. When a spinning object rotates, it resists changes to its orientation due to the angular momentum, which makes it useful for stabilization and navigation. Application of gyroscope: aircraft and spacecraft navigation and stabilization, smartphones and gaming consoles for motion sensing, stability control and navigation system, balancing and orientation in automated systems, ship stabilization and navigation. Now let's see what a MPU 6050 sensor is. It is both a gyroscope and an accelerometer. It is a 6-axis inertial measurement unit that combines a 3-axis gyroscope and a 3-axis accelerometer on a single chip. Pins of the sensor. VCC, it is a power supply pin, provides the operating voltage to the sensor. Operates between 3.3 volt to 5 volt depending on the module. SCL, serial clock line, used for 12C communication. It is connected to the SCL pin of the microcontroller. SDA, serial data line. This pin transmits and receives data between the gyroscope sensor and the microcontroller. It connects to the SDA pin of the microcontroller. INT, interrupt pin, used to signal specific events. ADO, address select pin, sets the 12C address of the module. GND, it is the ground pin, connects the module to the ground of microcontroller to complete the circuit. Now let's move to infrared sensors. Infrared sensors are electronic devices that detect and measure infrared radiation. They are widely used in various applications due to their ability to detect heat and motion. There are two types of infrared sensors: active and passive sensors. Active sensors emit infrared radiation and detect the reflected radiations from objects. They consist of an infrared light source like an LED and a detector. Its applications are proximity sensing, obstacle detection, and line following robots. Passive infrared sensors. These sensors detect infrared radiation emitted by objects without emitting any radiation themselves. They sense changes in heat patterns in their field of view. Their applications are motion detection in security systems, automatic lighting, and energy saving devices. In this video, we have seen accelerometer, gyroscope, and infrared sensors. We'll continue with a few more sensors in the next video.